Hi, I'm Caroline.
I'm Divya.
I'm Alex.
And I'm Jay, and we are all 10th grade students who worked on our project, Riglink. Thank you so much for stopping by to watch our presentation, which won the award for Best Digital Technology at the 2020 OTC Energy Challenge. We hope you enjoy this presentation.
The Offshore Technology Conference is an annual event hosted by oil industry leader BP, along with other oil companies. These oil companies host an energy challenge for high school students in order to design solutions so that the oil companies can look to more sustainable futures. OTC is designed to challenge and innovate young minds and drive STEM learning. Every team is given a choice of two prompts from which they will choose one and design their solution around its guidelines.
The challenge that we chose was called Twice as Nice. Our challenge was to create an onshore operation, an oil and gas platform from another location, to recreate the offshore environment to simulate and control activity on land. They referred to it as a twin facility, and a requirement was to ensure that changes in the physical environment were reflected in the virtual one, and vice versa. It was mainly to address safety issues that engineers, maintenance teams, and more face on offshore platforms, as well as address efficiency.
Here is the official prompt provided to us by the Offshore Technology Conference. In video games, we can control activity in a virtual world. Imagine being able to operate an oil and gas platform from another location, recreating the offshore environment to simulate and control activity offshore. Many disciplines are involved in operations such as inspections teams, maintenance teams, engineers, operators, logistics, just to name a few. Your solution needs to ensure the right type of information for their activities is being displayed and accessible for their role. There are occasions when multidisciplinary teams need to collaborate to resolve an issue. Your solution should demonstrate how those teams would interact between the virtual and physical world, as some personnel will remain on the oil platform.
Thus, the challenge. Design an operating facility for an offshore operation that is run via an onshore twin facility or working environment, allowing for people to collaborate and access from multiple global locations. Your solution must ensure alignment on an as-is basis between the physical and digital environment, i.e., changes made to the physical must be reflected in virtual and vice versa.
We were instructed to create a poster and a video that is up to 5 minutes long, and we're supposed to receive a $1,000 stipend from Village to fund any necessary materials for the project, such as research and supplies.
Our project integrated offshore rig operations via Internet of Things, a cloud network with enhanced cloud encryption and cybersecurity, to an onshore operations center outfitted with virtual reality infrastructure facilitated by data received from various sensors on the offshore rig.
We worked throughout this year on the project, and after coronavirus impacted us in March, we faced a total of a 7-month setback before the Offshore Technology Conference went ahead and decided that they would host their conference, which was supposed to be this spring, virtually in December of this year to announce the award winners.
We learned a lot throughout the year-long process. We learned a lot about the oil industry, persevering in the face of adversity, and being adaptable to ever-changing situations. Likewise, we had the opportunity to collaborate with industry experts. They gave us a lot of insightful information, mentoring us throughout the process, giving helpful feedback, and aiding us in our growth and understanding during the project creation process. After initially finishing the project, we went through a meticulous revision process for over a month and a half that our industry mentors were crucial to. This was most helpful in our poster, which you can see shortly. And through this revision process, we learned a lot more about condensing a lot of complex information, graphic design, what is appealing to the human eye, and simplifying complex concepts to make the information accessible to a wider audience.
You can see the elements of graphic design on our poster, which is on the screen now. This poster was one of 2 elements necessary for our submission of the project.
With that, Here's the video explaining our project Riglink in more detail, which we submitted to the 2020 OTC Energy Challenge.
I'm Divya. I'm Caroline.
I'm Jay.
And I'm Alex, and we're the Twice as Nice team from the Village School, collaborating remotely from locations across the globe to demonstrate the future of remote offshore oil rig operations management.
Currently, human safety is a large problem in offshore drilling. Over 349 severe injuries are reported on US rigs per year. There are also large mental health incidence rates among rig workers. Secondly, a lack of communication between operations teams and rig management results in poor decision making, which both decreases operational efficiency and minimizes utilization of human resources and skills. However, this is where Riglink comes in, by linking rig operations with onshore office users to create safe and productive working environments.
Assumptions we are making are that offshore platforms are able to connect to the internet via satellite, and that technological advancements will allow faster communication with near zero lag time at a low cost. In addition, because we are utilizing existing regulated technologies, we do not have any policy concerns. So, how does Riglink work?
Great question, Caroline. To create the Riglink system, all existing sensors on the rig, such as rig floor safety alarms and pore pressure sensors, will be retrofitted with wireless ones to create an Internet of Things network, which allows us to transmit the data they collect. From there, the data is then sent to the gateway for analyzing and onward into the cloud. Users then connect via internet to a gateway network, which is protected using a security firewall to access the data collected from the sensors. By doing so, users are able to manage rig operations in real time from anywhere across the world as long as they have a stable internet connection. But can people do anything with this data?
Definitely. The Riglink allows users from any one of the command centers, which are located across the globe, to access rig data through an immersive 3D virtual reality experience. The experience they receive differs based on their specialty, such as geology or engineering. This is done by digitally rendering a model of the rig, which is constantly updated with new data received from sensors offshore. By collecting this data, we can optimize well performance and track the longevity of components so that we can predict possible future failures. Users interact with this virtual model to perform standard rig procedures such as cementing and drilling. In addition, the alterations users make are immediately communicated to the rig so that they are implemented in real time. The user's changes are implemented on the offshore rig through autonomous machinery. These robots will enact on instructions sent by VR users from the command centers. All robots are fitted with 360-degree 4K cameras, allowing users to view live rig footage. A team of 10 specialists stay on the rig to assist the robots, and they receive assistance from onshore experts. So, what people are actually needed to achieve this plan?
A few specialists required to create Riglink are data scientists to analyze and organize data, software engineers to develop rig monitoring platforms, and mechanical engineers to install necessary rig hardware. However, how does your system actually solve the problem?
The positive impacts of Riglink are endless. Most importantly, human safety is improved. Relocating people onshore to office spaces eliminates safety concerns posed by machinery, and as a result, risks are reduced. Furthermore, communication becomes more efficient, and human skills are better utilized. Another impact is that it decreases carbon emissions by reducing the need for helicopter travel to rigs, which can emit over 7,000 pounds of carbon dioxide per flight. Lastly, costs are saved. The initial cost of implementing an autonomous rig is about $57.5 million. Automation saves about $25.5 million a year per rig in efficiency by using predictive maintenance, reducing headcounts, operating in adverse weather, and processing faster than humans, meaning a break-even is reached in about 2.2 years. Compensation costs for injuries and deaths are nearly eliminated, and the likelihood of oil leakage is mitigated due to increased reliability. So let's summarize Riglink.
Overall, Riglink is a great system. The platform uses wireless sensor data collected from offshore oil rigs to create 3D virtual models accessible through the cloud via internet in real time. Users are able to monitor and remotely operate oil platforms from remote locations. Changes made in the virtual model are mirrored simultaneously by the autonomous machinery on the rig to push drilling ahead. Riglink mitigates human safety risks, increases efficiency, reduces expenses, and links offshore operations with onshore management to create a more sustainable oil production environment across the globe.
Thank you for watching our video to learn more about the OTC Energy Project today. We hope you enjoyed learning more about the technology that is used to go into creating safe and productive working environments on oil rigs today, and in addition, modernizing the oil future for a more sustainable tomorrow.